My name is Sarah Brock, and this is my Pythagorean Theorem proof project. The definition of the Pythagorean Theorem is the square of the length of the hypotenuse of a right triangle equals the sum of the squares of the lengths of the other two sides. The theorem is, in a right triangle with legs A and B and a hypotenuse of C, that would equal A squared plus B squared equals C squared. So I had proof 96. It was made by a guy named John with a tricky last name. I'm going to attempt it. Molokach. And so this is what he started out with, just a basic large triangle, and it looks like it's a small acute angle that is like doubled into this bigger triangle. So when I first looked at it, I was like, oh, it's just two triangles put together, that's easy, but he actually goes into a lot of detail, and there's a bunch of triangles within this, and he came up with two separate proofs, and I picked the simplest one that kind of just puts it straightforward and into terms. So this is what he came up with and how it works. So this is the simplest one, and basically he broke it down into three right triangles. So you have the acute angle that we saw in the slide before, it's still there. That's a right triangle. And so then you have this one coming down, a right triangle also, and then it splits off right here to form another triangle with a right angle right there. So it's pretty much just three right angles, triangles, and the equation of this triangle is m minus a over n equals n minus b over n, and that equals a over b squared. So pretty much it's just three triangles put together. The other one was way more complex than this, had a lot of different triangles in it, so both ways work. And backstory, he was actually just playing around with all this, and he didn't even know, like, he proved the Pythagorean theorem, and then people were like, you proved it and all this, and so he actually got published for this proof. So it was really cool, and he had to go back and do it because it wasn't valid. So he came up with two more. So this is one of his along with the other one. Thank you.